Hey guys, so today we're going to be looking at polynomial inequalities. So the first example we're going to be looking at is going to be negative 5x squared plus 12x minus 4 is less than negative x minus 2 times x cubed. So the first thing that we have to do is we have to move all the terms over to one side. So over here I'm moving the terms on the right over to the left side, and I'm also expanding as I go. And then I'm going to put that into the standard form of a polynomial, which is the highest exponent to the lowest exponent. I'm going to call that polynomial p of x. So according to the integral zero theorem, the factors of this polynomial can be within the factors of the free term. And we're going to call that factor b. b can be among plus minus 1, plus minus 2, or plus minus 4. So we're going to try all the possibilities until we find one that works. So the first one is going to be p of 1, which is equal to 2. We're going to try p of negative 1, which is equal to negative 18. And then we're going to try p of 2, which is equal to 0. So therefore, x minus 2 is a factor of this polynomial. Then we're going to use synthetic division to divide this polynomial by x minus 2. So we write all the coefficients, and then we're going to do some adding. And by the time we're done, we can rewrite our polynomial p of x as x minus 2 multiplied by x cubed minus 5x plus 2, and that's less than 0. Once again, we can use the integral zero theorem, and we can find that p of 1 is equal to negative 2, p of negative 1 is 6, and p of 2 is 0. So therefore, x minus 2 is once again a factor of our polynomial. Then we're going to use some synthetic division once again. And we can finally rewrite our polynomial as x minus 2 squared multiplied by x squared plus 2x minus 1 and less than 0. So then we're going to use the quadratic formula in order to find the 0 of the quadratic x squared plus 2x minus 1. So according to the quadratic formula, our zeros for this part of our polynomial are going to be negative 1 plus minus root 2. So then, using our initial polynomial equation and also the most recent one that we have derived, we can rewrite our entire polynomial expression as x minus 2 squared multiplied by x plus 1 minus root 2 multiplied by x plus 1 plus root 2, less than 0. And then we're going to use a sign chart in order to find out where this function is strictly below the x-axis. So on the left, we're going to write all the factors of our polynomial. And on top, we're going to write all the zeros of our polynomial, which is where the polynomial function crosses the x-axis or touches the x-axis. So for the first factor, x minus 2 squared, it's always going to be positive throughout the entire domain of the function. The second factor, x plus 1 minus root 2, changes sign at negative 1 plus root 2. And the next factor, x plus 1 plus root 2, changes sign right after negative 1 minus root 2. So using these signs, we can find that our polynomial p of x is going to be negative only between negative 1 minus root 2 and negative 1 plus root 2. So therefore, x is in open bracket negative 1 minus root 2, comma, negative 1 plus root 2, open bracket. The reason why it's going to be open brackets is because the function has to be strictly less than 0. So therefore, it cannot be equal to any of the zeros in our sign chart. And there you go.